Hi and welcome. My name is Gloria Flucha. I'm Submer Marketing's Director. Here I am from our headquarters and factory in Barcelona, Spain, streaming live with all the team that will be with us during the session today. So this experience, how is going to work? During this session, we'll have our team with us, our expert team, making some introductions and theory, and then we'll go through live demonstrations of the technology and the products. You have to keep in mind that we have attendees coming from all over the world and with different profiles. So we'll be making some introductions that could be kind of obvious from some of you, but for the others, well, it will be the first time that they've seen. And now let's take a look of the agenda that we're going to be doing during today. We'll be having an introduction of the modern world and Immersion Cooling by the hands of Daniel Pope, our CEO. Then we'll go with Paul Valls, our COO, to check our live demonstration of our Smartpots. We'll continue with Peter Cooper to explain to us the best kept secret of Submer, that is our Smart Coolant. Proceeding with Adrian Whelan to check our data center in a box, the Micropot. And we'll be finishing before the Q&A with Scott Noblum to check why we like to say Submer Datacenters that make sense. We'll be also able to have a live chat with our experts team. You'll be able to write these questions anytime. They will be there to answer you, even though at the end of the session, you'll have some time also for Q&A. And now, let's introduce our first speaker, Daniel Pope, our CEO.
Thank you, Gloria. Thank you.
Hi, Danny.
Hi, and thank you everyone for attending. Let's, I guess, walk through some of the challenges that the industry has.
Let's see what's happening over there. Over the world.
Yeah, one of the biggest things that we're facing in the industry, or one of the biggest challenges, is of course this increasing amount of compute per rack, and most specifically, GPUs moving into the data center space. Technologies like AI and machine learning are accelerating that. And of course, blockchain and crypto mining, which is another big trend outside of the, I guess, pure data center. But also how to run all this compute, which is distributed now. A big challenge, how to run AI infrastructure on the edge. So the challenge of more density, less latency, distributed infrastructure, some of the biggest challenges that we're facing.
It's understanding more density as the much compute in less space, let's say, no, for our attendees that are...
Yes, absolutely. So essentially kilowatt per server U, or kilowatt per node, where we're transitioning from, I guess, the medium data center rack being in just 3, 4, 5, maybe 6 kilowatts per rack, where now today there's some HPC deployments in the range of 60 kilowatts per rack. So how to accommodate that, how to bring that into facilities that weren't originally designed for that type of capability. But that's also tied into an environmental challenge, which is the amount of energy that's being consumed, crazy amounts of energy being consumed to run all this digital world that we live in. And for example, all the internet infrastructure consumes the same amount of electricity than China, and emits the amount of CO2 between 2 to 4 times the amount of CO2 that that commercial air travel is generating. So a big planetary challenge, I would say, from an environmental perspective that we truly need to figure out how we solve. And how do we truly position data centers to be more sustainable? And sustainability programs that leverage technologies that really do reduce these consumptions.
So we have technology challenges, but also planet challenges, let's say.
Yes, and not just the electrical challenge, the water challenge. So data centers consume large amounts of water. Usually a medium data center evaporates an Olympic swimming pool of water every 2 days. And that's because evaporative cooling is the type of technology that is usually used in the secondary cooling loops. So how can we what technologies are available to allow us to limit the amount of water that's being consumed, and at the same time that's going to allow us to facilitate site selection, because one of the biggest challenges that data centers are facing now is I need to make sure that the site I'm selecting is going to be able to supply this amount of water during its lifetime. And the water that's being used for data centers today is mostly drinking water. So another
it's alarming.
2 Olympic swimming pools of drinking water, an Olympic swimming pool of drinking water every 2 days. This is more of a technical challenge, I guess, how to improve the efficiency of data centers. So the Uptime Institute, which is an organization that provides certification for data centers, at the same time also supplies a report on power usage effectiveness. Power usage effectiveness is a measure that allows us to understand how much energy is required for cooling IT infrastructure in a data center. And their latest report, the 2020 report, which was just released a few days ago actually, is showing that we're stalled since 2013. The efficiency in data center has not improved. And at Submer, we believe that the next level of efficiency is only possible through changing the actual medium that is used in data centers. So air is for sure a limiting factor today. So why immersion cooling? Well, everybody, we all understand we're coming from air cooling environments, where these, I guess, the typical rack density, as I mentioned, is between 4 to 8 kilowatts. That's what you tend to see. Again, if we're trying to to achieve this new level of efficiency and at the same time try to solve some of the planetary challenges and environmental challenges that data centers are causing in the industry, there's some liquid cooling technologies that are already available, already being adopted at scale, most specifically liquid direct-to-the-chip cooling and also immersion cooling.
It's a nice, a difficult balance to have between which resources we use while we respect the planet, and we also achieve enough densities for the high technologies that we need to use every day.
Absolutely, and not only that, we need to make sure that that from a TCO perspective, whatever technology we implement is going to make sense, because if it's going to cost more than what we're implementing today, it's impossible that it's going to be adopted, right? So direct-to-the-chip cooling is a technology that obviously pushes water directly through the hot components in a server. It has its challenges. I think the image is very descriptive of some of the challenges that it has, a substantial amount of pipe work and risk of leaks, and those leaks being a conductive liquid like water. But the rack densities can be increased. The cost is not too far off compared to air cooling environments, and it has also quite a few benefits, of course, around energy capture and energy reuse, etc. Immersion cooling, which is the space where Submer operates in, is a bit of a different approach. We completely submerge the IT equipment into a dielectric fluid that we've developed and that we'll be talking about in a while. And that liquid just changes the medium that's around the servers, and it captures the heat, it transports the heat in a very efficient way. It protects the IT hardware, as we'll be showcasing in a while. And overall, it allows us to slash the energy costs, increase the density, and it brings some other side benefits, like if I deploy immersion systems in the edge, I have this protective barrier around the hardware, which is also very beneficial in harsh environments.
And how specifically immersion cooling works?
Well, so immersion cooling is it's changing the medium, as I mentioned. So essentially instead of air, using a liquid, which is non-conductive, capturing the heat from the IT equipment and transferring that heat to a water loop, which is taking the energy outside of the building or allowing for energy reuse. Because it operates at very high temperatures, meaning an immersion system will typically run at between 50 and 60 degrees centigrade. It means that the water loop temperatures are also in a similar range. And that, at the end of the day, we'll see it now, I think, in a slide that I'm going to show. It means we can use dry cooling infrastructure in the exterior of our data centers instead of chillers and compressors and evaporative type of cooling systems. So essentially the energy footprint per kilowatt is a fraction from that 1.6 that's being reported by the Uptime Institute down to 1.03. Again, why immersion cooling? Of course, there's a big market. It's accelerating. Not only all the efficiency and density that I was describing, but also there's a true market behind it. The growth is very aligned with the data center construction growth as well. But also very exciting to see that there's 29 million devices that are going to be connected to the global network by 2022, and half of those are going to be deployed at the edge. And so for us, the edge and leveraging immersion cooling at the edge is super strategic, and we're going to run you through one of our products. How does it work? As we were mentioning, there's a water loop connected to the immersion tanks. The tanks transfer the heat through the cooling distribution unit, and my colleague and co-founder Paul is going to get into the details of that. But the CDU technology, cooling distribution unit technology, captures the heat from the IT equipment, it transfers it to the water loop, and that water loop runs either outside, or we have a heat exchanger in between to where we can activate energy reuse. But the whole idea is that it's a very simple installation, a redundant pumping system for the water loop like any data center has today. And the outdoor coolers or evaporative coolers, chillers, etc., if they're replaced with dry coolers, that's where we gain the biggest efficiency. And you can see from this slide that most of the temperatures, or the temperature range at which we operate, and this is a very conservative temperature range, allows us to run the dry cooling infrastructure anywhere on the globe without having to chill the water.
Okay. And when is the immersion cooling the smart choice, let's say?
Well, resuming, if you have any of the challenges that you can see here, and I think there's not a single data center out there that doesn't have them, immersion cooling is an option, a future-proof option, which is available today with the technology that Submer brings to the market. And of course, we'll also be talking about some of the innovation that Submer is going to bring in the very near future. We have some very exciting announcements this year. And my dear colleague Scott Noboom and our CTO will be talking also about that.
Okay, so I think that was great for our theory. Now let's see our technology live by the hands of Paul Valls. Paul, do you need some help, or you want to start and then I can go help you?
We're going to start, and you can meanwhile come here to the stage. Thank you everyone for coming. So welcome to the Submer booth here that we set up for you. And we are showcasing our portfolio solutions that we are using today with customers around the world, and that solve all these challenges that Daniel just mentioned a while ago. So all these things converging now, problems with the energy usage of data centers, massive electricity being invested in compute, more than India as of today. We are wasting a lot of water also. We have all this impact problem, but also on the other hand, all these technologies converging related to high performance computing, densities, AI, blockchain, etc. All these kind of technologies behind the scenes of your apps every day need something to run. So this is where we make things basically more efficient, sustainable, and powerful to make sure that everything works smoothly. And Gloria here, please help me unveil the technologies that we develop at Submer.
So
Let me
let's
see
try
if I
to make
can
it
do it.
right. I'm not sure if I could, but let's 1, 2, 3. Woo! Almost.
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 Okay. So We have here more or less, I would say, what we can basically deploy today, what we are using with these customers from HPC to colo to hyperscalers to telcos, from the edge and far edge up to the hyperscaler. So the Micropot will be covered later by Adrian, so I won't talk about it. But now let's talk about the SmartPot platform, the SmartPot X, XL, and the option XL Plus. So this is, I will come here just to explain a little bit more on detail the technology. I will open the lid. So I'm sure that you can see also from different angles and top. As you can see, we have different sizes of the technology. We have the half rack unit, the SmartPot X, and the full rack unit. So as you can see, it's like a regular rack. Just to recap, so we saw these problems before, and the thing is, with these problems that the industry faces, with this technology, basically what we did is putting together the know-how of different sets of engineering skill sets, hardware, mechanical, electronics, chemical, engineering of even robotics and thermodynamics, of course, that allows us to basically save more than 95% of the cooling operational costs for your data center, and we can increase densities by tenfold. This means that we can end up saving 85% of the real estate in some cases, and you can have the same logical capacity in these tanks in one single unit compared to 10 to 20 traditional racks. So these massive densities allows you to use hyper-convergent hardware and basically virtualize the logical capacity that you would have otherwise in many, many racks. And then we have a different medium, so we can basically protect the hardware. We have like a ambiotic fluid, something that allows us to operate smoothly the hardware. If you notice, there's no noise, and these machines are running. If you go to a data center, it's extremely noisy. This is because it's a Zen environment for the hardware. We don't have particles in suspension flying around, creating short circuits. We don't have dust, no sand, no
vibrations, right?
Exactly, no vibrations, no moving parts, no things that basically damage the hardware as aggressively as you could see in a traditional data center. So in this case, we actually enlarge the lifespan of the hardware by 30%, and we reduce hardware failure by 60%. We don't use moving parts, we don't need fans, so we actually also optimize not only the PUE, which is 103 if you look at the facility PUE, but if you zoom in into the hardware, we optimize also the IT usage effectiveness. So basically, 10 to 25% of the electricity is being wasted by fans within the server, so it doesn't make any sense. What we do is put sense into the data center, and what we have is basically, let me drive through the technology. We have the brain here, which is the CDU, the cooling distribution unit. This system has a redundant pumping and heat exchanging system with digital temperature, flow rate, and level sensors that allows us to monitor how this fluid behaves and how much compute you exactly have in the tank. This means basically that we can have somehow low density rack, but also a super high density rack, even up to 50 or more than 100 kilowatts per rack.
And Paul, what about number of views? And this can, I mean, all kinds of servers can be combined here, or?
Thank you for the question, Gloria, because I missed that point. This is very interesting. As you can see here, we have a hybrid environment just for demonstration, but we have customers in colo data centers that actually use this kind of setup. But if you notice, we see these mounting rails here that allows us to put traditional 19-inch servers. So these are, basically we are totally agnostic to the hardware. In this case, we have some traditional servers. And then over there, we have open compute hardware. So we have the 21 inches width of open compute and open use. So you can use open use or traditional use. And in the same space, you can even combine it. If you look at the bottom, we have the busbar system so that we can power directly in DC these servers. So this allows us to, of course, leverage open compute, the standard from Microsoft, Facebook, all these hyperscalers. But also, on the other hand, you can think on the under the holistic perspective of the full data center. So you can also try to optimize the AC to DC power conversion. Mm-hmm. This means that you can feed and streamline DC power. If you have access to renewable energies, locally you have microgrids, you can leverage energy storage, et cetera, you can avoid these AC to DC power conversions from generation, transportation, the UPS, the power supply, the motherboard, etc. It's also an important chunk of the PUEs or the PUE calculation. No? What else? We have, as I was mentioning, the CDU, which is the brain.
The brain of the machine.
Exactly. So we only invest the exact amount of energy needed to make sure that we dissipate the heat in the tank. This allows us to be ultra efficient, but also allows us to have a lot of resiliency. If you notice, this is basically, it has a few buttons. You don't even need to touch them. It's autonomous. But it has, of course, this dual pumping system. And for certain tasks, you can optionally select the pump. In this regard, we have redundancy per CDU, but also you can replicate and have a dual CDU system. So this Micropot XL allows us to have tier 4 configurations also. I will open the lid. So Jose, please, if you can help me. So this is what we call the dry zone. In the dry zone here, we have a way of basically handling all the power source for the servers, so the power distribution units and all the cable management. It's a mirrored dry zone. This allows us to do it in both sides. So basically, we can put PDUs, we can configure different shelves for having also extra hardware that you don't need to submerge, for instance, switching equipment. And the interesting part of the CDU, if you noticed also, is that it has the form factor of a server. This means that for the first time, you can operate the cooling the same way you can operate the any kind of hardware. So Jose, if you can help me, you can also see that this is like a garden connection somehow, but without any leaks. So this means that you can hot swap the CDU while the water is running. It's totally easy. You have a crane, like you have any typical data center crane. It can be manual, it can be motorized, and you can replace any kind of server, but also you can replace the cooling.
And Paul, I understand too that if you take out the CDU, the system will still work in for an amount of time, just in case there are any kind of challenges.
Exactly, that's a very good question, and this is due to the thermal inertia. So if you think about it, when you have a downtime in your air conditioning system in a traditional data center, you have 5 seconds, and everything goes down because of the heat. In this case, we have thermal inertia, so we have more than enough time to swap the CDU without downtime, even though, again, we have redundancy per CDU, and you can have maintenance, plant maintenance, but also you can have this tier 4 configuration with 2 CDUs. But in any case, worst case scenario, you have reaction time to act on your infrastructure. More things that are relevant, I would say I would grab this tablet here, so that, as you can imagine, this exposes certain telemetry. So optionally, you can have an integration from a typical data center infrastructure management software, so that you can basically see the information that the Micropot is exposing.
So its own software to control everything, I guess, right?
Exactly. Of course, under the security perspective, you can control if you want to expose it to the cloud platform or not. So otherwise, you can have a local instance of this telemetry. And as you can see here, we can see the basically information regarding the PUE, the dissipation capacity, the actual temperature in the bath, and then you can configure also the or see the real-time information on the pumping system, the heat exchanging process, etc., etc. All this is also exposed, if you want, optionally, through an open API to be integrated flexibly anywhere. So it's very, very easy to monitor not only your Micropot, but also your data center or edge data centers or any kind of infrastructure you have deployed, so many data centers. We have the Submer portal also that allows us to monitor everything in that regard. And let's talk a little bit more on the hardware itself. You notice that we have this hybrid environment. We have many types of hardware. You can also deal with it physically and hot swap components here. As you can see, you see lights, everything is working. These power supplies, I'm not dying. It's totally safe. It's actually good for the skin. You will see later Peter explaining more on the chemical side of things, which is very, very important. And anyway, as I was saying, we are totally agnostic. So
What do we need to know for people to understand if there's any adaptation for any kind of hardware or server to be immersion cooled?
Exactly. So the main thing to take into account or consider is that any moving part, or for instance, fans, cannot spin at the same speed as in air. This basically means that you use solid parts. So in the end, you either remove fans or deactivate them. By doing so, you already save from 10 to 25% of the electricity. And then what we do is using solid-state drives or spinning drives, which are helium-sealed. So in the end, it's basically the norm nowadays. And we don't have moving parts. By removing moving parts, also, we lower a lot the hardware failure rate. So it's a very practical approach. You can retrofit hardware. You can put strange hardware somehow. You can use FPGAs. You can use ASICs. You can use 19-inch servers. You can use Open Compute. And also, we also have a lot of partnerships with OEMs that allows us to not only optimize the efficiency side of things and make sure that we lower the TCO and the cost of the capex of the hardware because of not needing certain parts, but also they optimize from factory hardware for you to make sure that you take the most out of the density. So you can have hardware out of the door already optimized for this technology without the fans, without the expensive chassis parts that you don't need, and in the end, taking the most out of the densities and so on. So totally flexible, and not only within the tank, but also outside the tank. So it's very relevant to understand that these form factors are basically thought under the perspective of data center operators. We somehow understood the pains of dealing with hardware from day one because we had our own data center. So this is, we try to translate this know-how into how to make the technology usable, and also under the perspective of the financials and so on, making it cost-effective. Regarding the agnosticity on the location, you can see that this is horizontal, and you may think that occupies more space. Of course, thanks to the densities, we end up saving up to 85–90% of the space by leveraging the densities that this is capable. But in the end, this is future-proof. You can keep adding more hardware over time, which is more and more dense, and you will be saving more space over time and more somehow also capex in the building if you want, because we don't need the raised flooring, we don't need the cold aisles, we don't need the false ceilings. It's just raw space, placing the boxes, and very, very modular. Whenever you want to scale, you just put more boxes. Very simple.
And not just optimize the space in that regard, but I also think that you can optimize it even more because they can be stacked vertically, right?
Yeah, we have configurations where we can take advantage of the height of the building. So by not needing the raised flooring, you can leverage the already existing buildings and take advantage of this verticality. But then if you don't even have the building, you can also save a lot of capex by having raw space or a containerized solution. It's totally agnostic. So in the end, the magic of this technology, and especially our implementation, is that we've made possible self-contained, rackable, redundant per tank system that is agnostic to what's inside and what's outside. So you can connect a secondary loop to a dry cooler, or you can even, we have customers exchanging the heat with a heat exchanger in a river, or leveraging the technology for aquaponics, growing plants, and district heating. So in the end, we are agnostic to what's outside. These are boxes. You can put more boxes, and we can help you, of course, sizing and configuring the full turnkey solution. So, of course, we have the full know-how in the company in terms of thermodynamics, chemical, and so on.
Okay, so to conclude, let's say that it's agnostic, efficient, flexible, and eco-friendly. So I don't know what else, but okay. And I think that all of this is great, but of course, anything of this would not be possible without the magic of our liquid. So let's see. I think Peter is already waiting for me on the sofa to check our best kept secret, the Smart Coolant. Hi, Peter. How are you?
Hi, Gloria.
So what can you tell me about the Smart Coolant?
So the Smart Coolant is our dielectric fluid that we have developed in-house in Submer. The Smart Coolant is a synthetic hydrocarbon fluid that has been developed based on our years of experience with a wide range of immersion cooling fluids.
Okay.
So compared to other immersion cooling fluids available in the market, the Smart Coolant is actually one of the few that's been tailor-made for electronics. So what makes the Smart Coolant so special? To explain that, I'm going to talk to you about 3 features of the Smart Coolant. The first of those features is that the Smart Coolant has a 15-year lifespan. This comes from the fact that we've designed the coolant to be completely non-corrosive, non-oxidative, and on top of that, since it is a single-phase fluid, there's no evaporation loss, which means you don't need to replace the fluid over its lifespan. The second feature is that it actually protects IT hardware. So it acts as a barrier against dust and moisture, which are typical problems you would experience in an air-cooled data center. Another way it protects IT hardware is protecting against thermal hotspots, so it provides a medium with thermal uniformity. And also it is in a sealed environment, which means that it will actually increase the lifespan of your IT hardware.
Because it's protected with the liquid in a safe environment, let's say.
Exactly.
Okay.
And the third feature I'd like to talk about is the fact that it is environmentally and people-friendly. And this is because we've designed the Smart Coolant to be completely non-toxic, biodegradable, and it also non-flammable.
So it's eco-friendly and people-friendly, let's say.
Exactly.
Okay. It has a lot of friends, our Smart Coolant. Perfect.
Perfect.
And what can you show us? I mean, this is the theory, but do you think we can see something like real life so people can understand all that you say, like it's true, so they can believe us?
Sure. I've got some demo prepared just now.
Okay, let's go. Let's go to the other set. So what is this, Peter?
Okay, so what we have here is actually a glass of Smart Coolant. So as you can see, the Smart Coolant is completely colorless. It's also odorless. And we've just been talking about how the Smart Coolant is people-friendly. But what does that really mean? So what we can actually do is a bit of a taste test here. Would you like to try the Smart Coolant?
Are you sure?
Yes, yeah.
Did you work on the taste?
Yeah.
No, you didn't work on the taste.
That's to
Okay.
come in a future version. However, it is completely safe to drink like that. And that comes from the fact that when we designed the Smart Coolant, we only chose food-grade molecules. So, and that allowed us to achieve food-grade certification from NSF International.
Okay.
So,
So we don't have to drink the Smart Coolant. Okay.
while you won't be drinking the Smart Coolant while you're running the data center, it does go to show that it's completely safe for humans.
Okay. And what is this kind of printing machine, Peter?
Right, so this is our dielectric breakdown tester. So what we have here is one of our instruments from the lab. We have a lab here where we carry out lots of analysis to ensure the quality of the Smart Coolant. And we have here a cup with 2 brass electrodes separated by 1/10 of an inch. And in this test, what we're going to show is a comparison between air and the Smart Coolant. So most people, when they see this water-like liquid, they get worried because we're always taught liquids and electricity don't mix, right?
Kind of dangerous, right?
So I'm here today to prove that old theory wrong. So what we're going to do first is a test in air to have a comparison. So let's close this for safety. And we're going to start this test. Now, during the test, we're going to ramp up the voltage between those 2 electrodes, 2,000 volts per second, right? So let's see how long it takes for there to be a spark between these electrodes. So if we start the test and wait a few seconds, you'll see that, oh, now there's been a little spark, right? So in air, it takes 8,000 volts before you'll see a spark between those two electrodes. Now, let's take the smart coolant and repeat this test. So you would expect, right, that being a liquid, it would take far shorter time for there to be a spark. But let's see if that's true. So repeat the test now. Start the test again. So now we're ramping up that voltage. We're now over the 10,000 volts, and there's still been no spark. So what you'll find is that the smart coolant is actually rated to be better than high voltage transformers. So it's rated to have 50,000 volts of potential before you'll see a spark between these electrodes. And that goes to show that it's actually 6 to 8 times less conductive than air.
Wow, that was kind of exciting to know.
Yeah.
So is there anything that you need to show us, or?
There's one final test I'd like to show. And this is a question we often get asked about flammability. So to do that test, we're going to take our blowtorch over here, and we're going to see what happens if we shoot the blowtorch at a server submerged in smart cooling.
Okay, so now we're going to go to the other set with the pots.
Mm-hmm. Okay, so for our final test, what we're going to look at is flammability. This is a question we often get asked by customers. Is the smart coolant a danger to my IT hardware? So what we have here is a blowtorch. And what we're going to do is demonstrate that instead of being a risk to your IT hardware, the smart coolant is in fact a protective feature. It actually acts as a fire blanket.
Just in case, I'm going to remain here in my spot.
Yep. So let's turn on the blowtorch then. And as you can see, nothing happens. And this is because the smart coolant has a really high flash point. Even if we put it directly at a server, nothing happens. So this would be madness if you were doing it in an air-cooled data center.
Yes, please do not try this at your own data center or home. This was just a secure demonstration. So that's great, Peter. So we can say that smart coolant is actually secure, protective for the hardware, and 8 times less conductive than air. So pretty much a secure environment for your IT.
Exactly.
Thank you, that was great. And now we're going to see our data center in a box by the hands of Adrian Whelan. So he can show to us our latest Submer technology. Hi, Adrian, how are
Hey, Gloria. I'm good. So
tell me.
Micropot. Okay. So first of all, as Gloria said, this is our newest member of the family, our baby member. Like all small things, they are the best things that you can basically have. So this is Micropot, our data center in a box. Before I show you exactly how Micropot works, maybe I'll just take a minute to explain the background to the product. The concept started, as Paul was mentioning earlier, on looking at some of the systems in the SmartPod range that are used in data center. Those customers, particularly telecommunication customers, were asking us to say, okay, how do you take the benefits you've got in a data center and put it outside in any type of environment? And that's basically the concept where we came up with Micropod. It works fundamentally on the same principles, and I'll explain a little bit about that in a moment. But the huge benefits it gives you is you can take a liquid immersion cooling with high density equipment into the edge environment. So if you think about telecommunication towers, you can really start to deploy these systems on top of buildings for the 5G rollout. And then the list just goes on. So we've got customers looking at healthcare. We've got customers looking at emergency service locations in really harsh environments. We've got customers looking at it for oil rigs, customers looking at it for trains, etc., etc. So this product was basically started in March of last year, and we launched it in November of last year. So you can see how quickly we can take an idea from a customer and ourselves, design it, and deploy it. So that's enough about me talking about Micropod.
You're not going to show me a little bit of it?
Ah, yes, we will. We'll show you
Okay.
how the magic happens. So, the way Micropod's set up is there's two elements to it in the single unit. On here you have the chiller and the pumps, and on here you have the housing for the IT equipment. So, let me explain a little bit more by opening the lid. So the way we've set it up is you've got a chiller and the cooling system here. They move up to 90 litres of the same smart coolant fluid that Peter gave you the great demonstration with the blowtorch. That moves through the system. Before we get inside, and if you want to come a little bit closer, I'll show you inside the tank. But here we have Tamper Switches. So again, going back to Paul's demonstration on the software, if anybody tampers with the system, we can see remotely at any time. We also have the sealants, which I will show you now. So it's completely sealed. So if you look up inside, oh, excuse me. The seal basically means no air, nothing can get inside it at all. You can get no dirt inside it, it's completely sealed. So the same benefits from the smart coolant that are used in the larger tanks, you get into the smaller environment.
So the hardware is protected and perfectly safe there in its own smart coolant environment.
Yeah, absolutely. So now you get to the fun part. So inside the tank, this is the real benefit that we're seeing the customers are really excited about. So you can put high density equipment, up to 6 years worth of IT equipment inside this small environment. So that basically means, you know, if you look inside the tank, you will see there's a switch, standard switch. You have the fluid. It is real. I know it looks clear, but it is there. And here is a node that really starts to show the benefit. So this is a extremely high dense, ruggedized IoT server node. You can basically populate in here. You can put two of them on top of each other. So if you think about that logically, you can start to put more and more capacity inside a smaller space. And
Okay.
I mean, that's the principles of how it works. Some basic fundamentals. Inside here, you have the same quick connect hoses that you have in the main smart pods. The weight of it currently is just under 300 kilograms. We will be getting that down to 200 kilograms. And that, in essence, is Micropot.
Okay. And I understand that it's called a data center in a box because as a difference as the smart pods, it has the tank.
Yep.
And then it has also the secondary cooling
Yep.
on it. So
Yep.
it's like the perfect solution, all packed and ready
Yep.
to use.
Yep.
Okay.
And it has connectivity, standard connectivity as well. So you can pretty much put it anywhere.
Wow. Really a lot of things to a data center in a box.
Cool.
Okay, thank you very much, Adrian. Now I'm going to go back to the sofa where Scott is waiting for me so we can talk a little bit about data centers that make sense. So, hi, Scott. Tell me all about data centers that make sense.
Sure. Well, before we do that, isn't it like exciting what, when we go into what makes sense in a data center, the first thing that comes to mind is it's almost like we've come to a dance and we've learned how to dance, and now we're looking at all the equipment dancing. And now when we reflect back, part of like what kind of defining what makes sense in a data center is really two parts. First of all, now that we're doing the dance, looking backwards and saying, what if we were at the dance earlier? What kind of difference could we make in the world? And then looking forward to how can we better learn to dance with everyone else in the data center and what that can kind of do for the future. So when it comes to data centers that make sense, I've got about 10 things that range from energy and water and building sizes and hybrid interoperability between things. What is kind of the cloud kind of cost of capital relative to data center and compute infrastructure. So those are really some of the dynamics that are like the founding principles behind
A data center
data
that
centers
makes
that make
sense.
So going back into the past, we look at things and go, well, what are the driving factors that make data center, what drives their costs? And what's interesting is what drives their costs also tends to drive a cost on the planet. So when we look at things, it's, in construction on the capital side of things, what is the size of the building? And what we know now is with some of these better density scenarios that are denser, and not only that, but can also stack upwards that we're going to look at, that could save hundreds of millions of square foot of building if we were to do over again.
Optimizing space, cost, everything.
Yeah, totally. And then the other would be like electrical and mechanical systems. Those are arguably your two biggest costs in building a data center. And when you do both of those things right, you can make really big differences. So like a classic example is one of the things that I'm really proud of, we made good progress and we're continuing to make progress, is our basically our density of cooling, the delta between our temperatures. And so like a classic example is in the data centers of old, we would chill chilled water to 55 degrees.
Yeah.
And what people don't really realize, because here we are in 70 degrees Fahrenheit, is the server is very happy, and to be very specific, the CPU and GPU of the server needs to be cooled to 100 C, which would be 212 degrees Fahrenheit. So, in data centers of past, it was very common to let's chill water to 55 degrees, use that to chill air to 72 degrees that we blow across the server, and it becomes very inefficient. What we're doing in our technology today is we're now at a point where our delta is decreasing. We're using 95 degree fluid to be able to cool that 212 degrees. And what I can tell you is, and I'm really excited, is how that delta is going to continue. Like I think we're going to see within the coming couple years, fluid that can be 150, 160 degrees to cool that delta. And the difference is just in doing things like that, which is what we're a big part of, is we can save massive amounts of water. So our objective is data centers of the past, looking back at the dance, use about 156 billion gallons of water a year. With the technology that I'm describing, we can use 0 water a year. To put that in perspective, we live in a planet that some projections say 2/3 of the planet in a 15 to 20 year period is going to struggle to have drinkable water. The volume that data centers use today is basically could hydrate almost 900 million people a year.
Wow, too much.
So energy, which is the last one and is arguably the biggest part of building the data center from a cost perspective, by improving that delta, increasing the density, we can save massive amounts of energy, the equivalent of $10 billion in operating costs when you look at the global data center footprint overall, annually, which goes back to 15 million households worth of electricity. So those are some of the big things that make sense in regards to financial sense for the data center, but also makes sense for the health of the planet, which is also really cool and fulfilling.
So for the companies, it will be a lot of benefit from the TCO perspective, financial perspective, and then, of course, for everybody in a planet environment of how we can be smarter in the use of resources, of course.
Yeah, and then as we look forward, the other thing is how can the dance get better as the technology advances? And there's some of these things like basically the interoperability, like how can fluid complement air cooling, which to some degrees will exist. I believe that the TCO for fluid cooling will easily over time come down to the 10 kW rack level, which most people think that's an air cooling area, but because fluid also makes the operation of the server more reliable, I think it's going to come down, as well as even the 1 megawatt rack in the future. And then there's always going to be air cooling as well. So we're working on a lot of technologies of how do you get those two technologies to interoperate really well together, meaning how can we use gray water that comes from the ground at 55 degree temperature to cool everything from an immersion cooling perspective, heat that water from 55 to 95F, and then use 95F water for traditional like evaporative cooling for air cooling. So again, the dance of the future really isn't air versus fluid, it's how things interoperate together to complement each other. Same thing, data center with energy storage systems. Those kind of reflect the future of basically energy in the data center, because energy storage is required for renewable energy to work. So thus, renewable energy, energy storage, and data center all has to interoperate together, which gets into the other thing, which would be like basically energy supply and cloud demand orchestration. So just like air conditioning systems and electric vehicles have to orchestrate with the cloud and energy systems so that renewable energy can become reality in the world, so does the data center. So it's really fun to be part of all of that stuff that makes sense from a dollars and cents perspective, but also for the planet.
And what about robotics and automation? I know it's one of the points important on what Smart DC it's for us, right?
Yeah, so let me move, so by the way, in regards to like making sense, these are existing data centers that are around the world that we have deployments in. And like I said, right now they tend to be, people think of us as this is this niche for high performance compute. And what you're gonna see is while this is great for 50 to 100 kW, again, I see ourselves expanding to the 10 kW rack on one side and expanding to what I believe will become to be the 1 megawatt rack on the high side. And I think fluid complements all of that. So some of those scents that we're talking about are starting to happen around the world, which is fun. But to get to automation, so going back to density, and I talked about buildings, you know, that's like $65 billion just in building shells that we could save by doing things like this, which is when you're in a fluid environment, you can now stack infrastructure because air, we're not dealing with heat that rises due to air. It's all held within the fluid. So being able to do that enables things to stack. And then once things are, you know, stack, then you start looking at how do we get robotics into play, which is a big part of our mission. And so it's so interesting to look at this drawing. This was so early compared to the secret stuff we're doing in the lab. It's fun to look back at this. But robotics are absolutely going to be key in the ongoing serviceability of the data center, which not only makes a cost impact, but also helps remove the number one point of failures and downtime in the data center, which is human error.
Wow.
So that's kind of fun. And again, a lot of data suggests that, you know, it's, boy, in this drawing you see the
it's already a
stackable
necessity.
warehouse. Yeah, absolutely. To kind of close, one of the things that's most exciting and a key step that is kind of necessary for robotics is as you can kind of gather, traditional servers are really designed for like human hands, you know, RJ45 fiber connections and this and that. And some of the early movements we make that we're really proud of and we open source is how do we start making the backplane of the server into the rack, whether it's an immersion tank or a standard vertical rack, so that there is no cabling, everything just plugs in.
Compatible with immersion and standard racks, great.
Yeah, absolutely, and it goes from, you know, a fluid connectivity perspective, a network connectivity perspective, which then is going to enable robotics to really do their thing in regards to working 7x24, installing nodes, so on and so forth. So yeah, that's robotics, which is another fun thing.
Great. Thank you very much, Scott. That's it from the Data Center That Makes Sense section, let's say. And now I would like for the team to be placed more or less in their spaces in the set. I invite also Daniel Pope to sit here with Scott in the sofa. And we'll start with the Q&A. Danny?
Yes. Hi,
Danny.
Good to be back again.
Okay, so the first question is for Peter Cooper, because I see here in the chat that they're asking about the Smart Coolant. Are there any specific requirements for the liquid replacement? Any maintenance, refill, Peter?
That's a great question. So as I explained before, the liquid actually has a lifetime guarantee of 15 years. And this comes from the fact that we've done a lot of extensive testing around aging. Some people will say to us, how do you know it's 15 years if you haven't been around for that long? And that's because we followed many standard tests on where we deliberately oxidize the fluid. And we found that after 15 years, not only does our smart coolant still fall within the used fluid guidelines, it actually falls within the new fluid guidelines. So we're talking about a fluid which really doesn't oxidize at all. The other point I'd like to make is that it's, as a single phase fluid, there's no evaporation loss, which means that unlike two-phase fluids where you would have to replace the fluid over time, with this single phase smart coolant, you don't have, that's not an issue anymore. So basically over the lifetime of your data center, you don't have to worry about any kind of maintenance with a smart coolant.
Okay, I think that answered the question. Let's go to the next one, just for a few minutes to finish the Q&A. Danny, I think that could be answered for you easily. What other components or what secondary cooling equipment do you need apart from the pods, from the Micropot, the SmartPod X, and the SmartPod XL?
Okay, so in the case of the Micropod, you really don't need anything else from a secondary cooling perspective. It's a fully embedded, integrated system, so it has its own secondary cooling device. So it's a plug and play. You hook up power, network, and you have a data center in a box, essentially. When it comes to the SmartPod platform, of course, there's much bigger heat dissipation occurring there. The way it works is, and we've gone into the detail, the heat's transferred into a water loop, and that facility water loop can be connected to different subsets of secondary cooling technology, be it chilled water loops that data centers already have implemented, leveraging maybe more efficient dry cooler technology because you can run these systems anywhere on the globe with warm water, without chiller and compressors, etc. We're very fond, and we see a clear trend in the industry, which is considering energy reuse, so heat reuse, and how that heat can be transferred to district heating systems, greenhouses, etc. So between those smart pods and the secondary cooling infrastructure, you could have a heat exchange, an additional heat exchange occurring where the heat is being transferred to another network, to another heat network. Yeah, that's basically the typical installations that we encounter across the globe, I guess.
Danny, one of the things I'll add that I'm like most excited about is I was just talking about like the cooling delta, and as we decrease the cooling delta, as we get to the potential of say 70 degrees C fluid cooling to that 100 degrees C CPU, then we can actually use that heat to use some technology called like organic ranking cycle technology, that then we can use that heat to actually generate electricity that then feeds back into the data center.
Retrofeed in the
Yeah,
system.
so instead of a cost to cooling, the heat actually becomes an asset instead of a liability, which is fun.
Yeah, and as I think as the technology, as we see more and more adoption and server manufacturers designing systems for immersion cooling, what we'll see is that delta truly getting higher and higher temperatures out of the systems. Yeah,
Nice.
absolutely.
Okay, that was a really complete answer. Thank you. And then we're going with, let's say, Paul. Paul, people is asking why we should work with Submer versus other companies in the data center liquid cooling space. What's the difference with us, let's say?
That's a nice question. I would say under the technical perspective, we have many, many benefits and stand out. As you can see, we have the full stack know-how on the technology, so hardware, chemical, software, robotics. So we truly are basically understanding the technology, and also from the day one. So we had this data center background, so in the end, the usability and the pocket, the total cost of ownership, was one of the basic things that we considered when developing the technology. So now we have control over everything. For instance, you don't have to top up the fluid every now and then. Everything is aligned with the interests of the end customer in terms of having a resilient and basically a very, very efficient technology in the long run. We have redundancy per tank, so totally safe. You can hot swap the cooling for the first time. It's basically totally flexible, agnostic to the hardware. You can use OCP, traditional servers, FPGAs, ASICs, we don't care. So we don't have lock-in with any, that's another important thing. We don't have any lock-in with particular technologies or vendors. We want to freely be open to operate with any kind of different hardware, but also the location. So agnostic to the location, being able to place it anywhere. It's just a box, very modular and scalable. You can just put more boxes or put them anywhere in any climate. I mean, on the technology side of things, check all the boxes. And under the business perspective, we have a lot of seniority in the team, experts in the fields. Our CTO, Scott, that just spoke, former infrastructure director from Apple and Yahoo, so we understand our vision also. We have senior people, ex-Intels, ex-Ingram Micros, et cetera, so this allowed us to not only understand the technology and have a very or perfect product market fit with the different scenarios, but also we have a good network of partners worldwide. So we have a company which is also an European company, but also a US entity. We have investors from Europe, but also from the US. We also have now expansion in Asia, et cetera, et cetera. So basically, I would say it's comparing apples to apples, it's the logic choice, and yeah, it just makes sense, I would say.
Thank you, Paul. Yeah, I think that answers the question. Then we go with Adrian with the question of the Micropot. How cold can the ambient temperatures for the Micropot be when placed outdoors?
Good question. So when we were designing the product, we decided to pick the harshest environment there is. So our first deployment is going to be in the Middle East. And the temperature there that basically we're testing it against is up to 55 to 58 degrees. So basically we're going to run that in a way that we can really basically test the capability of the platform. So far, it's running fine.
Perfect.
So we picked the harshest environment to test our product.
Okay. And last one to Scott about the topic that we were just discussing before. How much time do you think we need, or when, in which year do you think more or less will be seeing a solid infrastructure, that it's autonomous, efficient, smarter than what the vision that we have right now of a data center? How much time do you think we need to achieve something similar to that?
Yeah, I think the next 5 years is really about igniting the fuse. And then I think once the fuse is ignited, the classic example is even some of the new, some of the evaporative cooling technologies that have worked in the past. Data centers were for many, many years, stuck on their old ways. This is the way we do things, and change is potential risk. Once that fuse gets lit, change can happen really fast. So I think the next 5 years are about kind of learning that dance between each other, how everyone dances with each other at the party. And then with that fuse lit, I think change happens really fast. So I think the data centers what we call a data center 10 years from now will be completely different than what we consider today.
Yeah.
That's exciting to hear, given that for the last 60 years, data centers haven't changed that much.
Yeah.
And ever the optimism.
Yeah.
It would be nice to have this picture of data centers from 10 years now and then after 10 years, so to see the difference.
I mean, we even are looking at some of it today. I mean, forget about 5 years.
Yeah,
and that's what's
true.
most exciting about being here.
Yeah, I think it's more difficult for us to make the evolution of the concept of how we want it to be than actually then apply it. It's more about which is the best solution, or designing how to go there, but of course.
Most of the challenges are actually more human than technology, because again, we're in a business where change is risk because it's potential downtime, and we have a lot of egos. I've been doing it this way for 20 years. Just being that agent and getting the people comfortable with things, the technology will be ready.
Yeah, the people is the most difficult part.
Yeah, totally.
Let's say we are difficult. Okay, so that was all for the Q&A. Thank you very much. If you have any questions, we'll be uploading all the information on the same landing that you get registered. So basically, you'll have everything there, also the recording of this event. So just look up the website and you'll be with all the information. Thank you very much for attending, and please follow us on our social media. Bye-bye.
Thank you.
Bye, thanks.
Goodbye.
Goodbye.
Thank you. Bye.